this video, I'll show you how to track air quality using data from the popular PurpleAir Air Quality Sensors. You can either use your own sensor or use public data from an air quality sensor near you and display it on a retro analog gauge that shows the color-coded air quality index. It is built with a Raspberry Pi, a Micro-Servo, an RGB LED, and a ProtoStax Enclosure along with some Python. Let's dig in, shall we? We're going to start by having the ProtoStax Enclosure in a platform configuration for easy prototyping. We're going to mount the Raspberry Pi on it as well as a mini breadboard which we'll use for the components. Next up, we wire up the various components as shown in the fritzing diagram here. The components are the Raspberry Pi, of course, as well as a Micro-Servo. We use the SG92R and an RGB LED of the common anode type, as well as some resistors. We use two 100 ohm resistors, a 430 ohm resistor, and a 10K pull down resistor. We're going to use the ProtoStax Micro-Servo analog gauge add-on as the top plate. We'll start by removing the protective covering to expose the clear acrylic, and then add the analog gauge scale for air quality index on top and attach the Micro-Servo to the top plate using some screws and nuts. Next up, we'll insert the plastic holder for the RGB LED, which we have wired up with male jumper wires for easy breadboarding, and we insert that into the plastic holder. And finish up the wiring to the rest of the circuit. Next up, we insert the analog gauge needle horn to the Micro-Servo. The position doesn't matter as we are going to be calibrating it. We then want to test the connections. We first start by testing the LED to see that the red, the green, and the blue lights work using Python program ledtest.py. So we want to test the limits of our servo. We do this by running servo test. The duty cycles usually range between 2 and 12, but those are the extremes, and we want to start off with being a little conservative. Let's try duty cycle of 3. So that is our maximum value. Let's try the maximum duty cycle is about, let's try 11. So 11 is a good number because if you do 11.5, it starts to jitter. So 11 is not bad. So then what we want to do now is we want to go ahead and set our 0 for the gauge. So get it as close to 0 as possible. Okay. Now we can fine tune it. Let's try 11.1, 11.1, and the min duty is 3 because for maximum value. And we also want to find out what is the duty cycle that would get us to 150 6.16 is the duty cycle that puts us in the middle. Next, we want to transfer these numbers to the AQI monitor.py program. Let's navigate to the analog gauge class and find the section which has the min duty, the max duty, and the center duty values, and replace them with the ones that we just found out. Let's go ahead and test our air quality monitor with a few stations from PurpleAir.com. Let's find a station of interest on the website. We then click on it, and in the pop-up we will navigate to the section that says get this widget. That in turn pops up another section that has the station ID. We go ahead and use that station ID in our AQI monitor.py program as a command line argument -s. When we run the program, we find that the data is returned from PurpleAir.com for this sensor, and includes the PM2.5 concentration value in the form of a JSON document. One thing to bear in mind is that the PurpleAir.com website by default shows us the 10-minute average values. A little further down, it gives us the current value. This is the value that we will be computing based on the PM2.5 concentration values that PurpleAir gives us. In our program, we compute our own 10-minute average with the data that we receive and store over time. Therefore, our computed value will get closer to the 10-minute average over time. Something to bear in mind as you test it out. Now that everything is working, we're going to go ahead and close up the enclosure. We do that by screwing in the vertical bracing elements, the sidewalls, and closing it up with the top plate. And then screwing everything in place with the top screws. And we repeat this on all four sides. Now we have our final assembled air quality monitor, and we're going to go ahead and power it on. And first thing that you might notice is the needle might move. This is because the GPIO is floating on power up, and this can cause some noise that results in the needle moving. So let's go ahead and repeat the calibration process after final assembly and double check everything. You can use your air quality monitor to provide a visual indicator for the air quality around you, and thereby take steps to reduce your exposure to bad air. And if the air quality is good, you can go out and enjoy it. You can find more details about this project, such as source code and how it works, on the project write-up on Hackster. You can also find a link to it at the protostax.com website by clicking on the Project Hub link. Both links are included in the description section below. If you like this project, then please go ahead and hit that subscribe button below and the bell icon to be notified when we publish future projects. Until then, we hope that you stay safe and well. See you next time.